Okay, let's look at question 34. In the figure below, the point O is the center of the circle. Therefore, in this case, O is the center of the circle. The line BC is perpendicular to AE. Therefore, BC is perpendicular to AE. All right, and the line CD is perpendicular to AB. Therefore, in this case, let me just draw this. This part is perpendicular to this part. All right, yeah. Okay, if the radius of the circle is 10 cm, find the value of OD squared plus CD squared in cm squared. All right, in cm squared. Therefore, I just need to highlight to you that this part is 90 degrees. Therefore, obviously, this is also 90 degrees. All right. Okay. Okay, let me introduce the notation. Can I let the length of BD to be x? That means in this case, can I say that this part here, this is x? Yes. All right. And then this part here is y. All right. Okay. Then I think I want to let the length of CD, this length here, to be h. This is h. All right. Yeah. Okay. Therefore, now can I say that? Can I look at? Can I just look at this particular expression r squared minus OD squared? I just want to look at this r squared minus OD squared. All right, and r squared, r is the radius, right? Therefore, can you see that this can be viewed as r minus OD? And then this is, I think a squared minus b squared. Therefore, is r minus OD, and then r plus OD, or r plus OD. Okay, right? R plus OD. And then what is r plus OD? R plus OD. Okay, can you see that? Take note. Take note. In this case, can you see that? Let me just look at this. This is R. This is R, and then plus OD. Therefore, can I extend this one to this point P, and then I extend, and I will get this point Q. I'll get this point Q. Therefore, R plus OD. Can you see that this is OD? Therefore, R plus OD. Please take note that R plus OD is actually DP. Take note, this point is D. This point is D. Therefore, this is DP. All right. What is R minus OD? Then can you see that this whole length here is R? This whole length here is R. It must minus OD. That means minus this part here, or minus this part. Let me just make it clear. Minus this part. Therefore, what you get is QD. What you get is QD. All right, yeah, QD. Okay. Therefore, we get this relationship first. All right. Then next, I want you to look at the right angle triangle. Let me just move up. Let me just move up. Okay, can you look at this right angle triangle here? Can you look at the right angle triangle here? Okay, this is Q, this is D, and then this is C, right? Then in this case, take note, this is H, and then this is X. All right. Therefore, can you see that? Okay. Sorry, this is B. I make a mistake here. This is B. This is B, right? Therefore, in this case, can you see that H squared plus X squared is equal to BC squared. All right. Okay, then let me look at the next triangle. Let me look at the next triangle. The next triangle is this one. This is 90 degrees. And then can you see that this is D, this is C, and then this is A. All right. And this is Y, this is H. This is H. Right. And in this case, can you see that H squared plus Y squared is basically AC. Is basically AC squared. All right. Okay, then we know that the area of the triangle. Okay, therefore now can I draw this triangle? Can I draw this triangle here? This is your B, this is your C, and then this is your A, right? And then I think this part here 90 degrees, and this is your D, right? Therefore, area of triangle ABC. When I put this square bracket, it means area of the triangle ABC is equal to area of triangle BCD, and then plus what? Plus area of triangle ACD, plus area of triangle ACD, right? ACD. Then in this case, how do you calculate the area of triangle ABC? Can I shift back a bit? or isn't that the area of this triangle will be just this base AC multiplied by BC. All right, therefore, can you see that this is basically what? This is basically half square root of h squared plus x squared, right? And then multiplied by square root of h squared plus y squared. That would be the area of the triangle ABC, right? Then how do you calculate the area of BCD? BCD is basically, this is x. Can you see that? Can you see that this part here, this is x, this is y, and then this is h. Area of triangle BCD will be x times h times half. All right. Therefore, can I adjust this part here? Therefore, this would be just equal to half x times h. And then ACD, this would be just half y times h. Take note, this is x. This is x, right? Therefore, now, can you see that? Let's simplify this expression. Then in this case, can you see that half and half cancel? Then can I say that I can square both sides? Okay, before I square, maybe let me simplify. H squared plus x squared square root, and then this is square root h squared plus y squared, and then this part here, this would be x plus y multiplied by h. Then now you can start to square both sides. Therefore, this is h squared plus x squared multiplied by h squared plus y squared, and then this would be just equal to x plus y bracket squared multiplied by h squared. Then can I say that you expand and simplify? You expand and simplify, you will get to this. You will get to h to the power of 4 minus 2xy h squared, and then this is plus x squared y squared equal to 0. Therefore, this is actually a perfect square. This is h squared minus xy, whole thing bracket squared, and this is equal to 0. Therefore, what you get here is this. What you get here is that your h squared is just equal to xy. Therefore, this is what you get. This is what you get. Then after that, I need to introduce the intersecting chord theorem. I need to introduce the intersecting chord theorem. Therefore, let me clean this part off. And I just want to highlight to you that, can you see that this is x, BD is x, and then your DA is y. Therefore, and remember just now I draw one line. I draw all the way, this is P, and then there's a Q here, right? Then by intersecting chord theorem, let me just talk about the intersecting chord theorem. In this case, can you see that QD, this distance here, this distance multiplied by DP, that means this whole distance from here to here, is equal to what? Is equal to x times y. This distance x, and then this distance is y. Therefore, this is what we call the intersecting chord theorem. Alright, therefore now let me just write down the proper thing so that you can understand. Therefore, in this case, can I say that by intersecting chord theorem, or intersecting chord? I think this one maybe you didn't learn it in the normal maths, but now I think you can just quote this theorem. Therefore, this is QD multiplied by DP, and this is just equal to xy. But I think, remember, I think on the first part, in the first part, I actually found this product, right? QD multiplied by DP. Therefore, go back. We go back here. Can you see that QD multiplied by DP? Can you see that this is here, right? It is actually equal to R squared minus OD squared. Right. Therefore, now go back. Substitute in. Therefore, in this case, can you see that that will be just equal to what? That will be just equal to R squared minus OD squared, and then can you see that xy is just equal to h squared? Right. Then in this case, don't forget what is h. H is actually CD. Right. Therefore, R squared is equal to OD squared plus CD squared. This is what they want us to find. Therefore, OD squared plus CD squared is just equal to 10 squared, and that will be just equal to 100. Right, and the unit is actually cm squared. With that I stop here. Yeah.